So today we are going to learn about the topics intensity of pressure and Pascal's law. So first starting with the intensity of pressure. So intensity of pressure is defined as pressure force capital P or capital F acting per unit area, that is A. So therefore intensity of pressure is denoted by small p. So intensity of pressure is pressure force divided by unit area. The unit which is generally used is Pascal or Newton per meter square or Newton per mm square. Okay, the MKS system of, if we talk about MKS system of unit, then its unit is kgf per meter square or kgf per centimeter square. And if we talk about SI system of units, then its unit is Newton per meter square or Newton per mm square. It is also referred as 1 bar is 10 raised to 5 Newton per meter square, and the another unit is 1 bar is 100 kilopascal, and where 1 Pascal is 1 Newton per meter square. So these are the units which you need to remember in case of intensity of pressure, and it is defined as the pressure force acting per unit area. Okay, so that is regarding intensity of pressure. Now let us see that what is Pascal's law. So Pascal's law, it is defined as that when a fluid is at rest, the intensity of pressure, that is pressure intensity at any point, is equal in all directions. So that is small px is equals to small py is equals to small pz. So Pascal's law states that when your fluid is at rest, means when your fluid is in static condition, the intensity of pressure that will act upon the fluid at any point will be equal in all the directions. That is, the intensity of pressure will be equal in x direction as well as y direction and as well as z direction. One more thing you need to note over here, that it is applicable to confined fluid and incompressible fluid. Okay, so this Pascal's law is applied to confined fluid and incompressible fluid when your fluid is at rest, and it finds its applications mostly in hydraulic systems, and those hydraulic systems may include hydraulic lift, hydraulic ram, then hydraulic press. It also finds its applications in the design of log gates, dams, etc. Okay, so these are the various applications of Pascal's law. So I hope now you are clear with the two topics over here, that is intensity of pressure, which is defined as the pressure force per unit area. This is the small p and this is the capital F or capital P, which are referred to as the pressure force. This is intensity of pressure and this is unit area, and it is generally expressed in terms of Pascal or Newton per meter square or Newton per mm square. These are its MKS and SI system of units, and also in terms of bar. Okay, and based on this intensity of pressure, we can define Pascal's law, and it states that when your fluid is at rest, this intensity of pressure acting on fluid at any point will be equal in all the directions, that is x direction, y direction and z direction. So in the next lecture we calculate an example which will be the applications of Pascal's law. Thank you.